Last week, I sort of hinted at this issue that more recent research on violent video games has been coming to conflicting conclusions relative to what earlier research on violent video games has found. And so this week, what I want to talk about is a statistical tool that we can use to try and make sense of these conflicting results. Basically, when we have conflict in research, how do we kind of try to resolve that conflict? And the tool we're going to introduce you to is this idea of meta-analysis. So let's go back to this hypothesis we've been working with all semester, which is this notion that playing violent video games would increase aggressive behavior. And so let's imagine that we conduct a bunch of studies in this realm of research, and let's imagine that 230 studies concluded that yes, there is this relationship between violent video games and aggressive behavior. Whereas 50 studies concluded no. And let's say these are all studies that have been published in the research literature. You might look at that and say, well, 230 studies said yes, 50 studies said no. There must be a relationship. There's far more studies that are suggesting that there is a relationship relative to studies that are saying that there is not a relationship. But what if I next told you that, hey, in fact, the null studies, those studies saying no, actually have higher internal validity than the studies saying yes? And also the null studies that are saying no have occurred more recently than the studies saying yes. That starts to kind of add more nuance to this question of, well, if the better studies are saying no, should we listen to those studies more so than the studies saying yes? If the studies that say no have occurred more recently than the studies saying yes, maybe things have changed over time, and we should sort of consider this time factor in our conclusions. And so when we have this sort of mixed evidence pool, it's a real question about what sort of meaning we try to draw from that evidence pool. And a meta-analysis is a useful statistical tool that we can use to summarize large bodies of research. And what's going to happen in a meta-analysis is that we're going to summarize the results of lots and lots of research studies by examining effect sizes. An effect size is a quantitative measure of the strength of a phenomenon. And that's a sort of an academic definition, but basically every study that we conduct on any topic, but including on violent video games and aggression, is going to produce what we call an effect size. It's going to say, we did this study, what was the effect, the numeric effect of video games on aggression? Was it big? Was it small? Was it non-existent? What was that effect size? And we're going to have a numeric, quantitative sort of number that we can pull from each of these studies to basically summarize what was the effect that we found in that particular study. And what the meta-analysis will do is average together the effects that we see in all of these available studies and basically say, we recognize that each study has its own limitations, each study is conducted very differently, each study has come to a different conclusion. Let's summarize that conclusion with this one number and average everything together and see what that conclusion says. When we look at all of these hundreds of studies that have been done, do they conclude that basically, yes, there is an effect, or no, there's not an effect? So we're going to get into some numeric things here and some statistical things, but they're very straightforward, and we're basically just using these numbers as like guideposts to compare other numbers to. So don't be too freaked out by these numbers. They should be pretty straightforward, and don't be too freaked out, hopefully, by some of the notation here, because it's all just kind of statistical notation, but it should be pretty straightforward. Basically, there's many kinds of effect sizes that could be drawn from a study. One is this thing called partial eta squared, which is this weird sort of little n squared p image symbol that we have here. And what this means is that it's the variance explained between an IV and a DV. So how much of the variance in a DV is explained in an IV? How much of the dependent variable is explained by variation in the independent variable? In other words, how much change in a DV can be explained by concurrent changes in the IV? How much change in the DV can be attributed to changes in the IV? So in other words, put another way, is that when I play more violent video games, when I play, like, for example, if I play 5 hours more per week of violent video games, how much change in aggression could I expect to see in myself or in others? So with every change in the IV, how much of the change in the DV could be attributed to that particular independent variable? And this number, this partial eta squared effect size, can range from 0 to 1. and basically 0 meaning that there's basically no effect, that there's no relationship between the IV and the DV, and 1 meaning that there's a perfect relationship between the IV and the DV. That with every change in the independent variable, we see an equivalent and exact change in the dependent variable. Another effect size that we often see is this effect size R, which is a Pearson correlation. This is maybe a number that some of you are more familiar with. It represents the correlation or the association between an IV and a DV. It describes how strongly two variables are related. And this particular number can range from -1 to 1. And so numbers close to 0 are again going to be no relationship. Numbers close to -1 or 1 are what we would call a perfect relationship. And in fact, you don't have to know this, but if we just squared R, if we took R squared rather than just R, it's going to be equivalent here to the partial eta squared. So we're basically looking at two numbers that are very similar in what they're trying to do. And basically what they're trying to do is say, how strongly related are these two variables? How strongly related is my independent variable with my dependent variable? In this case, how strongly related is video game exposure to aggression? So when we look at these numbers with partial eta squared, there's basically different benchmarks that we use to decide like what is the size of the effect that we've seen. And I'm just going to throw all these up here so that you can see, is that basically the number that comes out, again, it ranges from 0 to 1. And these numbers we sort of categorize as being basically 0, being small, being medium, being large. Because essentially what happens is that we're going to get this number and we need to be able to sort of talk about that more colloquially. When we get this effect size, do we call that a big effect size? Do we call that a small effect size? Do we call that effect size basically 0? We need ways to kind of talk about it more colloquially. And so these benchmarks just tell us kind of how we tend to categorize these partial eta squareds that come out of these studies. And so an effect size, a partial eta squared between 0 and 0.009, we basically interpret as that's close enough to 0 to say there's no effect size there. There's no relationship. An effect size between 0.01 and 0.059 would be considered small. Between 0.06 and 0.139 is considered medium, and between 0.14 or more is considered large. And so you can think there, if we're thinking 0.14 is sort of the variance explained between the IV and the DV, what that says is that like 14% of the variance is explained, 14% of the variance in the DV is explained by the IV, and that would be considered a large effect. So explaining just 14% of the variance in something is considered large, at least in the social sciences. And that's because it's often very, very hard to sort of predict human behavior. And so even when we're getting to that kind of even small number of 14%, we're considering that very large. And R, again, is just a different number, and so where you have slightly different benchmarks, but it's all for the same thing, that basically 0 is going to be between 0.01 and 0.09, small is between 0.10 and 0.29, medium is 0.30 to 0.49, and large is above 0.50. And again, if we're squaring these numbers, we're getting a sort of similar thing as we get with the partial eta squared. But overall, the idea here is just that we have these benchmarks, we're going to get a number in a study, and we're going to compare that number to these benchmarks to say, did this study find a small effect, a medium effect, a large effect, or essentially no effect? And we have two different numbers that different types of studies will generate. Some studies are going to generate a partial eta squared, some studies are going to generate an R. It really just depends what statistical analysis is used. So ways to think about, additional ways to think about effect size when we're thinking about variance is that when we're explaining about less than 1% of the variance in an outcome, we're thinking that these are basically imperceptible changes. These are changes that are so small that they're basically not occurring, or not occurring in a way that like is relevant to sort of human interaction. And then when we think about these other effect sizes between 1 and 6%, between 6 and 14%, and then more than 14%, we're thinking about small, medium, and large. And so as I previewed before, those like explaining just 14% in the variance of a dependent variable, we consider a pretty large effect in the social sciences. And we consider that large because social sciences are otherwise typically dealing in very small effect sizes. And that's because human behavior is complex and has many, many different causes. And so it can be really difficult to isolate singular causes, such as what is the unique effect of violent video games on aggressive behavior after accounting for all these other potential things that also impact aggressive behavior. And so social science is often dealing in these kind of small and medium effect sizes, very rarely getting into those large effects, and unfortunately sometimes talking about imperceptible effects, so really no relationship between certain variables. So all semester we've been talking about this issue of violent video games and aggression, so this relationship between the IV and the DV, and I just wanted to kind of quickly show you, we've talked about a bunch of studies so far this semester that have all generated effect sizes. We just haven't really talked about or identified those effect sizes in how we've talked about these studies so far. And so earlier in the semester we talked about a study by Anderson and Murphy. Later in the semester you read a study by Hassan et al. You also read a study by Williams, you read a study by Lin, you read a study by Adachi and Willoughby. And so these are all studies that have been assigned this semester. And we've talked about primarily the design of those studies. We haven't talked so much about the sort of statistical results that they found. But each of these studies looked in some way at the effect of violent video games on aggression. They used different video games, they used different measures of aggression in each of these studies, and they calculated aggression in different ways in each of these studies. But nonetheless, all of these studies have generated effect sizes. Most of them have used partial eta squared as an effect size, some of them have used R, but the point is that they all have sort of generated one singular effect size. And so I just wanted to pull up all those effect sizes here to show you what they look like in the context of these studies. And so the beauty of the meta-analysis is that we no longer just have to rely on the results of any single study, or we don't have to rely on our sort of interpretation of the results of any single study. What we can do instead is average together these effects, as well as the effects documented in hundreds of other studies that have been done, and try to draw a conclusion about what we see as overall across all of these studies, despite their differences, despite their limitations. What is the relationship between violent video games and aggression? So I'll kind of pause here for this particular lecture and just sort of just communicating the basic idea of the meta-analysis here. They allow us to make broad generalizations about a single research area despite mixed results, despite differences in methods and measures, and despite differences in quality. And the other thing that we sort of, I won't dig into too much, is that they can also correct for other concerns that we have, such as the quality of the study and publication bias that might exist in a realm of literature. So we have these statistical tools that we can use to kind of judge study design and judge publication bias in a realm of research, and we can incorporate that in our calculations. We can incorporate that into the averages we're calculating when we average these studies together. And so what we'll see in the next set of lecture slides is basically what have recent meta-analysis concluded about the effect of violent video games on aggression.